computer.
Okay, mission accomplished.
Yes, I just want to explain a couple things, but first, welcome everyone to the bnug meeting. Thank you for coming again. Great to see you all. Uh, I want to talk about, we just spent some time getting ready to record for the first time in a long time. And I think what happened was that Steve Eisenberg, our computer technologist, went through and cleaned up some settings in Zoom. And one of the settings he cleaned up was the ability for participants and hosts to record the meeting. And I think he read that to mean any participant or any participant can record the meeting without asking. That's not my understanding of the meaning of that. What it means is anyone can ask, but only the host can record without permission. Um, just to try that out, Stan, could you try recording the meeting at your end?
Good point. Yeah, let me see. Where is it? Where is it? It's down here on the bottom. There it is. Okay. Request permission to record on this
All
computer.
right, that's enough. That's what I wanted to know.
Yeah.
You can't just record, which is what Steve was trying to avoid. He was trying to avoid people recording
Right. On their own.
without asking permission.
Yeah.
Now, this is a classic example of the challenges of security, of picking exactly the right twist to get what we want, but not so much. And it's also a really interesting example of trying to get information from the web. And so this is where Martin and I have divergent views about Chat GPT, in that I think Martin is more patient than I am. And I want to recall from many years ago, a lot of us used LogMeIn, and it was free. And we used it for all our customers, and it was fantastic, and we were delighted. And then one day, literally one day, it may have been a week, LogMeIn said, "We're really sorry. We're now going to charge you $5,000 or some like crazy amount to use this." And I lost, as they say, I lost my shit. I got so angry. Martin, you're muted.
You're actually jumping over a few years. The first year it went to like $200. And then it grew to maybe three and then four. And then eventually it got to like 1,300, at least for me.
But they raised the rates without asking and without any kind of discussion after many, many years of being a free service. And at least for me, Martin, it was a much bigger bump. And anyway, I just got furious. I just felt like the way they handled it was so obnoxious. And Martin, being Martin, said, "Let me talk with them." And so Martin went and patiently talked with them and got a great deal. And so I really admire that about you, Martin. And about ChatGPT, I think that you probably are able to wheedle out some really good info from them. I, for one, much prefer getting information that has a certain pungency to it. Like, I would really appreciate it if this hard-won knowledge that I have after years of struggling with Zoom, the hard-won knowledge that Zoom puts some settings in its app and some settings on the web for no particular reason and without any kind of explanation. And it becomes really difficult to find out, where is this? Like, where is this setting? And I think that simple knowledge, if the search query started by saying, "Pal, I know this is not easy." Like, I think I, for one, need that from people. I really need someone to say, "Yeah, this is hard. Don't think it's you." And it's hard for me to get that from this Chat GPT, which is this weird hybrid between a query into a search engine and a weird kind of sort of human thingy that seems to be thinking, but isn't really thinking in the way that I find satisfying.
Okay, well, the next time I drag you into AI, we'll use Perplexity, which is somewhat more fact-based than creepy conversation-based.
No, great. So let's
but by the way, I asked the question, what is an internal meeting participant? And the answer basically says if they're part of your organization, if
yeah,
they're
the corporate.
Yeah.
Well, or part of, their email address is in your domain, basically.
Yeah, yeah. Okay.
Um,
Thank you. So I just want to announce to everyone that we have our first outside speaker in a long time. Mary Kay Laferno is a marketing and AI person who's been doing this for a really long time, and she's agreed to come and show her art. So we'll post that on the website at our board meeting, and I'm really looking forward to hearing from her. We'll give her the whole meeting.
um, oh, Adam, did you want to make me a co-host again?
Oh yes, thank you. Okay.
And Anna, may I say something about the meeting information?
Yes, please.
It does say that we're still at Mass Bay, just so you know.
Wait, let's look at that together because that's
Yeah, I don't know if it's appropriate now, but
no, it's very important. I thought we went out of our way to change that.
and I looked for May as well, and it does say that it's on Zoom, but also in person at Mass Bay.
Oh, let's take a look. It must be some leftover thing.
Are you referring to the bnug website?
Yeah.
Yes, yes.
Oh,
Hold on a sec. Thanks for pointing that out. We don't want anyone showing up there.
Yeah. Right. No signs.
Funny place here.
Hey. Yeah, come on. Website.
I don't know where I am in some weird Zoom world. Okay, here we go. Where are you seeing that, Tom?
Yeah.
So I went to meeting calendar.
Oh, that's something we'll need to talk with Steve about. Steve Eisenberg.
And then
Like you went to someplace like this?
I did exactly that. And there it is.
Yes. Okay, so I'll make a note to reach out to Steve and have him change that.
And it was on May as well. I don't know.
Oh yeah, it's a perpetual calendar.
Yeah. Yeah.
Yeah, so we need to change it. I don't think I have editing rights, but we'll find out. I don't.
Yeah. Okay.
Yeah,
That question.
yeah, that's the answer to the question. But Steve does, and he'll
All right.
fix it. Thanks, Tom.
You're welcome.
Yeah.
It's also such an example of where maintaining any kind of information like this website has two different places that says the same thing, and that makes things quite difficult. So there's actually a look at this. It's an email address.
Calendar.
Yeah, this is going to go to Steve. Although I want to hold this meeting in the Leland Cooperative Garden now that the weather's getting better, but I'm not sure how we're going to make that happen. Maybe we'll do a hybrid.
Here.
Okay. So that's splendid. Let's move on here. So as I say, we'll give Mary Kay the full meeting, but at this meeting, you're not going to get away with not learning something about how a computer works. I was very gratified to find out that on Reddit, there was a whole discussion which opened with somebody saying, I am a senior computer engineer. I don't really understand how this computer works. Could somebody explain it? So I thought it was I thought it was significant. Let's see, we need bnug. I thought it was significant that this issue is not just some weird issue I thought up. It's bear with me. Just gonna stop the share for that. It's
Universal.
a larger issue having to do with how computer training works and what's happened in the last 50 years. It's been a real time of ferment, and different people have learned different things. And so we have a lot of people who don't really know some really basic things because they've jumped ahead and gone on to become multi-billionaires and stuff. And so I think if we, at least our group, I want us to know this particular thing, which is how the plumbing works in a computer. And we're going to continue our discussion of the simplest possible computer because it's so much fun and exciting and interesting. But we also, I think, it'd be worth our while to go back to the beginning of this book for a few minutes and begin to do some lessons with Professor Malvino about the author of this book, about how a computer works in the most basic sense. So he opens by talking about number systems. And a lot of this, I think, will be elementary to a lot of people here. Am I right? That people know what decimal is, what hexadecimal is.
Yeah.
Is that right? And what binary is?
Sort of.
Sort of. Okay. Sort of means we should look into it. So let's do it. It's also really fun because you get to hear a really good teacher teaching you something that you already know. That can be actually very interesting. So let's go there. And this also asks the most important question, in my opinion, about computers, which we'll come across. So modern computers don't work with decimal numbers. What is a decimal number?
1 through 10.
It's what?
It uses the digits 0 through 9.
0 to 9.
Yeah.
And then more number.
Yeah, base 10.
That's base 10.
Base
And what is a binary number?
0 and 1 combination.
Yeah, binary numbers are much more limited. And this is the punchline of why computers do this. Electronic devices are most reliable when designed for two-state binary operation. This I think this speaks some real humility on the part of Sharif. I'm just muting you because there's some background noise. Feel free to unmute when you want to say something. Real humility on the part of the people who created the computers. They said, we just can't do better than this. We can't differentiate more than between zeros and ones. Once we start trying to measure the electricity, we're just going to get in big trouble. Let's just keep it simple, off or on. So then he's quotes Rene Descartes, who was responsible for creating the Cartesian system that we use for graphing, among other amazing things. And so he talks about an odometer, which I think is such a good example. So this odometer, what base does it use? How does it keep track of things?
It looks like base 10.
Yes.
Yeah.
Isn't it? Isn't that what an odometer is? Like it goes up to 9, right?
No, an odometer measures distance.
I understand, but the numbers are base 10, right?
Well, in American cars, yes.
Wait, in a European car, what would it be?
I was making a joke.
Kilometers, but it's still decimal.
It's got to be base 10 no matter what measurement you're measuring. It's base 10 because the odometer is designed when it gets to 9 to do a flip and turn on the next digit to become a 1, and then you get a 0, right? So when you get to 9, you can't go any higher because it's a base 10 odometer. So you add 1 to it and it becomes a 10. And this goes down to 0 again. Clear?
Yeah, sure.
Now, this unit wheel has got a reset and carry. So the reset and carry is where you bring the digit over to the next place and reset the first digit. So when you're adding 1 to this, you're resetting the first digit and carrying to the second digit. We've all done this when we've done our basic arithmetic.
So the computers.
And it's what the odometer does too.
Yeah.
After 999 miles or kilometers or versts in Russian, what happens next? When you go drive 1 more mile or 1 more verst?
It rolls over.
Tell me more. What do you mean rolls over?
Well, I'm sorry. If you're talking, this odometer seems to have 5 digits.
Yes.
But are you talking about one that only has 3 digits?
No, I'm talking about the one that's before you.
Oh, okay. Yeah, well, it doesn't roll over. It just bumps up to the next power of 10.
When you say bumps up, what is it in the terms we just talked about? It's carrying.
Yeah, sorry.
It
carries to the next,
And what does it do to the first 3 digits?
I'm sorry. Do you mean the last 3 digits?
Yes, I mean the first 3 digits in value, but the digits on the right. What happens to them?
Yeah, well, they roll over to 0.
Yes, but there's a special word for it called resetting.
Yeah.
Well, that's a new term to me in this context.
So we're going to learn that.
Yeah, right, because we know how an odometer works.
It's going to turn out to be really important. So it resets and carries. And so the numbers on each odometer wheel are called digits using 0 through 9. One more thing is a string is a series of letters and digits.
Okay.
Yeah.
Okay, let's just bear that in mind there. Okay. So we've done the reset and carry. Now we're going to do something really weird. We're going to create a binary odometer. Here's the binary odometer. First mile, you put a 1 here, right? What happens on the second mile?
Oh, it resets and carries sooner because it's a smaller base.
Yes, it carries, and then it resets the first digit. But it does it it can't get bigger than a 1. It's a special odometer.
Well, my odometer does both of those things in one operation. So,
yeah. What about tenths? Tenth mile.
That's a more expensive book and a different lesson. We'll charge you that one.
Fractions. You want to talk floating point? Oh my god!
But you see what's happening here?
Yes.
What's happening is that as you add miles, the flip or the reset or the bump or whatever you want to call it increases the next one almost instantly. Instead of waiting till you get all the way up to 9, it does it as soon as you've got a 1. You push things forward. So there's 3, and then you're suddenly at 4. This is pretty wonderful. And
Adam, I'm confused by when you say suddenly. I mean, you have to drive a mile before anything changes.
You're so right, but it's suddenly compared to how long it takes to do a flip with the old odometer. You have to drive a lot more before you have the exciting moment.
Oh, sorry. You're talking about the milestone moment, not the each mile moment.
Yeah, no, it's the milestone moment.
Oh yeah, you'll wear out the binary odometer before you wear out the decimal odometer.
Well, there you are. And we could say a lot about that and why computers are wearing out, but that's a whole nother story. Okay. So
now my stuff is all digital, so there's no little wheels that turn with gears.
Right.
Yes, I missed the gears. Okay. So we're now that we've done a little bit of that lesson, we're going to jump ahead. There's a lot more there. And there's a wonderful electronic stuff that we'll learn about how this gets translated into electronics. But what I'd like to do before we wrap up this brief programming discussion is to go to SAP 1, see if we can find it. Anyone who has an amazing memory could tell me what page this is on, but hold on. Remember, we don't have a searchable document of this. So hold on just a second. But you get to have a little preview to all these cool gadgets that we'll
Adam, you say it's not searchable, but at the top of the screen, it says this appears to be a long document, and unsaid is if you don't feel like reading it, save time by reading this summary using AI assistant.
Yes, I'm
Now it
just
seems
very concerned about all the buttons that Adobe has been adding to its programs. And I'm afraid that they're going to add something to my credit card by doing that. Maybe I'm overly
yeah.
nervous, but
Oh,
So they can read it.
Adam, this is not. So if you clicked in that text, you couldn't select anything?
right, because you might recall, I can select, but you might recall that this document, this PDF document, is not OCR'd. It was just scanned in. These are just photographs. And remember, we went looking for a copy that was, and it turned out to lead to this whole Shaggy Dog story of, yes, but you can only download this if you're a member of whatever. It was just like very, very annoying.
Oh, okay.
You
Yeah.
can't use OCR on this copy?
I probably could, and I haven't yet. So we probably could find a way to do OCR, like uploading it. It's a very large document, so and I enjoy going through the pages anyway because they're so cool. You get to see a ripple counter. You get to learn these were like a synchronous counter. Why not spend a moment just gazing at this? Isn't that beautiful? That's a synchronous counter.
Out of context.
As the clock clicks, it counts the number of clicks, the number of time the clock goes up and down. That's what this does. And it will turn out to be very, very important. The clock is like a really important part of this story. Yeah, I agree. The context would make it much more fun. Okay, so let me see if I can get past all this electronics. Thanks for your patience. There's some registers, pictures of transistors. Bus organized computers, so we're getting warmer. Because yes, here's the bus. Everyone see this bar in the middle?
Yeah, that's the bus.
That's the bus. And the bus, what we're about to see is that these wires that are going into the registers either say, you're on, man, get on that bus, or you're off, you leave the bus alone. And one of them lets you get stuff off the bus, and the other lets you put stuff on the bus. And if both of them are off, no busing at all. That allows us to have a single bus. Here. So there's stuff about memory.
Memories.
Very interesting story about the way memories have developed. We'll be able to look at those electronics at some point, which I look forward to. There's the thing about bubble memories. And some things about addresses. So just to get us warmed up here, notice the addresses, they go from low to high, upside down. Like, I don't know why. It's just the way people have done it with computers. So this is a very high address in hexadecimal. This is very
Yeah, it's Exodus.
even though humans say low is at the bottom. So that just seems very strange to me. But the people who created this had all kinds of pressures and ideas. But here we are. Good people with good memory, page 146 for next time. Okay. So we're going to start by reviewing the architecture. Here's this beautiful picture. There's the bus.
Mm-hmm.
See the wires going in? They're the things that either say, you're on stage now, Mr. Carey. When it puts you on stage, that means you get to put your thing on the bus. And it has another gadget that lets you take something off the bus. This is a gadget that doesn't put things on the bus ever. This input and memory address register. And that's why it doesn't have an arrow going that way and doesn't have a wire to allow it to go that way. Let's talk just for a moment about the program counter. So the program counter is a odometer, a binary odometer that starts at 0. And what it does is it puts whatever's in it, let's say it's all zeros, onto the bus. And then when it does that, this guy also gets turned on and pulls from the bus. So the very first thing that happens when the simplest possible computer starts is it takes whatever's in the program counter, puts it on the bus, and the input and memory address register gets it from the bus. So by the end of the first step of our dance, we have the current location, the current program counter number is now in this box. Very clever, because we're ready for the second step. So in the second step, the program counter is incremented by using this CP wire. And it's incremented by 1, like an odometer, and just keeps going up. Every time we go through the cycle, it's going to get increased by 1. We'll talk about greater complexity later. But that's the simple version. So the second step, all it is incrementing the program counter. Why is it doing it then? Because we don't have to worry about it later. We're not going to use the program counter again in this cycle anyway. Why not just get it incremented? Get your homework done early. So now in the second step, as we finish the second step, we have the input and memory address register having that magic number, which is the program counter. The program counter points to what the next program instructions are. Now, what are these program instructions? Where did they come from? They came from you before you started this computer. The way this old-fashioned computer works is that the programmer has to put in all the instructions into RAM by hand. So using what is essentially an odometer, it uses different variants on binary code to put it in RAM. So RAM has this large stack of instructions starting from that lower memory location going to the higher one. In this case, how many instructions can it hold? You can guess.
Is it one at a time, Adam?
Yes.
No idea. So,
How many memory locations do you think this computer has?
Well, how many digits are the addresses? I lost track of that.
They're 8-bit. 8 bits.
Oh, that'd be 256.
You're answering a different question than I intend.
Okay.
What I'm intending to ask is how many words, like we're taking the program counter and using it in the memory address register. It's going to point to a location in memory. That's what the memory address register does. How many different locations are there?
Well, if there's 8 bits, it's 2 to the 8th power, which would be 256.
I'm not quite getting that. That's the number of instructions?
Wait, I'm sorry.
no.
I'm sorry. You're talking about the when you said it's 8 bits, I misunderstood what you meant. You're saying an instruction consists of an 8-bit number.
Right. Each program counter puts 8 bits on the bus. The 8 bits come through here.
But I'm sorry, is that the instruction or is that the address of the instruction?
It's the address of the instruction.
Okay, well, if an address...
The program counter, it's actually which step it's in, but it uses that step to pace through memory. It goes through memory from 0 to however big it is. How big is that? How many instructions can fit in this RAM?
Well, I'm sorry. If you're saying an address has 8 bits, then has 256 different values.
Maybe I'm just not asking it in the way that I want to. Let me try that.
I mean, unless you're saying an instruction shares an address in the same 8 bits, in which case it depends how many bits the instruction takes versus how many bits the
you're getting more detailed than I intend. So okay. In the program counter, the very first program counter, remember this is an odometer. This is the first thing that comes out of the program counter. And it gets put in the memory address register. And it points to a location in memory. Now, what is memory? It's a stack of words, of 8-bit words, that starts at locations 0000. So this is the program counter, and this is the location in memory. And here are the choices. You can have location 0, very first location in memory. You can have location 1. That's the next location in memory. Location 2. You kind of get this, right? Okay. There's a number for each location in memory. The program counter points to that number. So the program counter is that. So in this case, it's going to point to this location. On the next step, when we cycle through again, it's going to point to this guy.
Yeah.
So the program counter is pointing to the physical location in memory. And how many of these are there is the question that I'm asking. There are 3. And remember, in each location in memory, there can be only 8 bits.
Okay,
Now,
but how many bits does the program counter value? Okay, well, I'm sorry. My answer is still 256.
Wait, I'm sorry. Maybe I'm not quite getting it. Yes, but there's a problem, Martin. You're talking about, in theory, we could go up to 256.
Well, I thought you were asking a theoretical question.
I was not. I was asking a
Okay.
practical question. In this computer, in the simplest possible computer, how big is the memory?
16.
Yes, that's what I was trying to say.
Right
Is
there.
that we only paid for 16 floors on this building.
Well, okay, but does memory include both code and data or just data?
It is the
It includes something. We don't know yet. We'll find out.
Oh, okay.
But the point is, there are only 16 memory locations on this computer. I know this is mind-bending given where we are now.
16.
And actually, this is not the best tool to demonstrate this. This program is much better I think, for illustrating what memory is.
Well, if there's only 16 locations, that's a 4-bit address space.
I agree, but wait, I hear what you're saying, but let's just illustrate what's really happening. So we have the program counter, and it's going to start at 000000. Sorry, it's a little difficult to work with strings here.
Oh, Adam, just hit the single quote.
Okay.
Yeah.
If
Okay,
you want to
so-
quote, if you want to use raw text and have it not mess with your numbers,
Yeah.
use the single quote prefix.
There's my single quote.
Yeah, there you go.
Okay. So the program counter is saying this, but here's the thing I want people to get in their minds today, and then we'll move on. This is the actual physical memory. And these are the memory locations. So they're going to start at 0. And then it's going to add up to 1. You'll see in a moment why I chose Excel for this. That didn't work. Try this. That didn't work either.
Sorry, what are you trying to do?
Trying to make it repeat.
Yeah, I'm going to make it add automatically.
Yeah, if you just select from there down to down another 15 rows.
1 second.
Yeah, Adam?
Yeah,
Yeah, just select however many rows you want it to fill in.
but it's supposed to, once it sees the pattern, it's supposed to
Well,
fill in. according-
selecting is not an action.
I got it.
There you go. Now let go.
Not done yet.
How far are you going?
16. We bought these locations. That's what we own. Now, in physical memory, there can be update. There's 8 bits, and we put any 8 bits we want in here. I'll have to use Martin's suggestion.
Yes, please.
Is that 8? Okay. So what's in memory? This is what's inside it, but this is the address. When I say I want to know what's in number 6, what I mean is what's here. This is very dull writing in this binary thing, But you see, This is what I want to emphasize and get in everybody's mind, including mine. The program counter is going to point to one of these 16 locations. That's what it does. Once it has the location, we can then do some interesting stuff with it. But I want to point out that the number of locations is simply 16. There's no more than that. We can't have any more of these words than 16. Does everyone understand?
Well, I get that you're saying it's a limitation of the system, but I didn't catch where it was specified.
I'm
Was
specifying it. I'm specifying it, but I'm basing my specification based on his picture. Let's look at it. Oops, 16 by 8
Yeah.
RAM.
Right.
That's what he's saying. There's only 16 memory locations.
Yeah.
Yeah. This
Okay,
is a very
yeah,
small computer.
Well, that's poorly defined nomenclature.
I'm with you, and that's why our job is to read this and make sense of it and help
Okay.
understand it.
Oh, fair enough.
He's not here to defend himself. We have to do our best. Good enough. So for the rest of the meeting, this is our intro, somewhat delayed by our interesting exploration of Zoom. For the next part of the meeting, we want to talk about remote access. So I want to invite people to share their remote access stories. I brought some of mine, but if some other people would like to comment or say something about remote access or ask a question, now's the time.
Crickets.
Well, one meta comment I have is over the years, as I've helped more and more dozens of people through remote access, I started a list of the things that I can't do or can't see or that are tricky over remote access versus being there in person. Like what you just went through earlier with that floating Zoom window that only you could see, but that was blocking your view of what I could see.
A wonderful example. And ironically, Zoom is actually one of the premier remote access programs for a bunch of different reasons.
Another is a problem I have with a couple of clients right now where what the remote, if you will, the transmitter on the client's computer sends to my computer, the helper, probably comes straight out of video RAM, which is independent of their monitor. So their monitor might, for example, have the brightness turned all the way down. I can't tell because I'm getting, if you will, raw pixels. Now, I could open up their settings and look for the brightness slider and infer that their monitor is turned down. Their monitor could even be powered off or defective, and I can still see what it should be showing.
Which is both a win and a lose there, right?
Oh, absolutely. I teased a client of mine whose laptop monitor was failing to say, well, hey, I can access your computer from over here. I can read you your email.
Right.
So absolutely, every one of these is kind of a tricky pro and con.
Okay. Do you want to share some others?
Oh, well, if the computer is slow, I can sometimes infer that when I click, in general, how do you say a computer's slow? Well, one measure is you click on an icon and how soon does it become selected? In general, it should be practically instantaneous. If the computer's really busy doing stuff, you could make allowances for, well, it's scanning for viruses and it's backing up and it's installing some updates. So you could be patient to say, when I click and then the icon selects. But suppose it took a minute. That would be, understandable if you knew why it was busy, but crazy making if you don't.
Right.
And these days, remote access doesn't add a whole lot more overhead. But I always try to make allowances for, maybe on a slow computer, it might be proportional. But for example, but a comparable thing is, does it show, as I fly my mouse across, your screen, there's an arrow cursor that's, let's say, is flying across the screen. Is that the live cursor position from the remote computer, or is it the local on my computer? Because you can get very confused about if I click, am I really clicking where I think I am? And some systems show two cursors, the remote cursor and your cursor. And sometimes there's a little bit of a pursuit going on. That
It
if
can
you
be, it can
pause,
be,
mine catches up.
it can be infuriating sometimes. So
Oh,
what I've
absolutely.
sometimes find is that the cursor that I'm using is out of alignment with the actual cursor of the computer.
That
And I'm
too.
trying to click shut to close a window and it won't close. And I think something's really wrong with this computer. And then I turn on the remote cursor button in my remote control software. And now I get to see what I'm really clicking and I can adjust for it and it makes me feel much better.
Oh, and that offset can drive you crazy. You're trying to drop a file into a given folder in a list of folders. You might put it in the wrong folder and not realize it. So, Adam's advice to me many years ago, as we were transitioning out of LogMeIn, was super, super helpful. He had thankfully researched a bunch of services, and he recommended both AnyDesk and Remote PC to me, and he recommended getting them both, which I did ever since his advice, because there are days when one of them is acting up, and I install both on each client's computer, in general. And if one is acting up, I can switch to the other one, which is super helpful because the client doesn't care, about the infrastructure. They just want to get the session done. They want help with the computer. They don't, I mean, yes, they'll sympathize if you're having trouble connecting, or you get kicked off and you say, "Hang on a second, I got to reconnect to you." And they, but it's super helpful to have, if you will, a primary and a fallback. And each service has a different style to it, both in terms of the actual UI, but also in terms of how do you express, as Adam said, show me the remote cursor. And we also have different magnification because often my clients have bigger screens than I do, or even if they have the same size screen, it's scrunching their screen down on mine because they're in a window on my computer. So by definition, it's a little smaller, if not a lot smaller, than their computer. So
I
yeah,
find,
there's all kinds of mapping questions.
I find this can get very frustrating. I have certain customers who use a particular resolution that makes it very difficult to read in full view mode, the bird's eye view mode. But then when I go into the more precise mode, I can't figure out where I am. I'm just disorienting.
Yeah,
Disoriented.
I call that nose to the newspaper. It's
Yeah,
like, where am I?
it's like that.
And Anna, may I ask a question?
Please.
So what is the resolution to that comment that you and Martin just made? And I don't use remote access that much based on my business, but there are times when I want flexibility and I will connect my laptop to my desktop through AnyDesk. But then based on what you just said, and I was going to bring it up tomorrow night at the clinic, me reading my laptop to see my desktop, it's as Martin described. I'm looking at the newspaper right up front, and I haven't figured it out yet. But if I can't fix that, then I can't see this being a tool for me to be somewhere else to see my desktop.
Well, which program are you using?
AnyDesk.
Okay, well, AnyDesk has an option in the little toolbar. There's like a generic looking monitor. If you click that,
I can either demonstrate or if you'd like to.
oh, why don't you demonstrate? My my stuff is buried under a lot of windows. But AnyDesk has basically an option A and an option B. There's no like you can't pick the percentage. It either squeezes everything in, or it's a one for one, you know, original size. Every pixel of yours is the same as a pixel of theirs. So you can in AnyDesk case you can pop out where it will basically fill the window that you have open. So what you can do is try to make that window as big as you can, depending on the size of your monitor.
Yes, that's what
Um,
I would like to do. Right now, the font and the information is so tiny. It's not acting as a tool. It's becoming very
so you want to magnify, you don't want to
yeah,
reduce.
I'm on the laptop side. My desktop is in my office. I want the flexibility to connect to my desktop so I can take my laptop, even if it's a different room in my house or away from my home office. But the font on my laptop to see my desktop in the programs and emails and things I need to get access to is so tiny.
Okay, so first step is you want to maximize the AnyDesk window so it makes the most use of your laptop monitor. Do you follow
Okay.
what I'm saying?
Yeah, so I'm assuming that any desk side on my laptop, I have to go to some type of setting to do
Okay,
that.
Hold on a sec. Let's talk
Yeah.
very concretely. So what you see, let me just share, make sure everyone can see what I'm doing here. So what
Tom,
I'm
I'm just saying to make it possible to see more, you want to start by maximizing the AnyDesk window. Don't just accept whatever size it gives you. And then the next thing you can do is make the settings change that Adam will show you.
Okay.
But AnyDesk only has basically two choices. Fill, make the desktop screen fill the laptop's window, or pixels are 1 for 1 and your nose into the newspaper.
No, we don't want the nose in the newspaper.
okay.
I'm sorry?
So right, we don't want nose in newspaper.
Yeah.
Yeah, no,
So basically,
no.
you want to fit,
Unless
not
you're
zoom.
hiding from the police who are looking for you.
no.
Okay, so we've got. I also want to, while we're talking about this, since we're talking about remote access, because I have RAdmin set up on these two computers, Arthur and Ceres. Our computers are named after our teachers, our school teachers, and theater teachers. Arthur Feinsod was my summer camp theater teacher, and Mr. Ceres was my high school theater teacher. It's a little drama in both places. Now, we'll make Arthur your laptop, Tom. We're going to imagine this is your laptop. And we're going to make Ceres your desktop. Because what you want to do is be able to sit in your laptop and connect to your desktop.
And I'm sorry, which one is my laptop?
We're going to make Arthur.
Okay.
Yeah, Arthur is going to be your laptop.
Okay.
Yeah.
Okay, so
So,
there's
so
Arthur.
the flower is your desktop.
Flower is the joy of your desktop. This is my cousin Stephanie's iris. Very beautiful, most beautiful. Okay, so what we're going to do is
Put one inside.
turn on AnyDesk on this machine.
Yeah. So Arthur, in my terminology, this is the transmitter. This is the person you're connecting to.
I think a lot of these companies will call it the host.
Well, yeah. I mean, I find those terms very tricky.
Yes, but they like it, and so I find it helpful to know it. So this is the Tom's desktop providing an address. Now we're going to go to Tom's laptop. And one of the beautiful things about remote access is I can go here, copy the address, use RAdmin to get the remote clipboard, set the remote clipboard on Arthur, and paste that address right in. So
Yeah. This is a meta level of remote access.
nice feature of it's the RAdmin method. Okay, so now let's see if I got it.
Yeah. Just hit the enter key. There you go.
So here's Arthur, and it's asking, in this case, for a password, which Tom, you'll probably want to set a good, strong password. Although you don't, I think in your case, you will want to. In this case, since I have access to this machine, I can just say accept. But I happen to know the password, so I could enter the password too if I wanted. But I'm gonna click on accept. And here I am. I'm just gonna shrink this stuff so we don't get confused.
Yeah.
Real easy to get confused. Okay, so I've shrunk this one, but I don't want to shrink this one. Oh, yeah, no, I'm doing great. So I'm in
The
where
laptop.
I am. I'm right now in Arthur, which is the laptop.
Yeah.
I'm on the laptop
Oh,
using AnyDesk.
Adam, could you pull Arthur so its window is fully on screen?
Uh-huh. So there be Arthur. So I'm looking at Tom's desktop, which is in the back here. This is what really is going on this desktop. I'm going to shrink Ceres just for now because we now have remote access. Here we are. I'm going to make this bigger for everyone.
Yeah.
And I'll make this bigger too.
Yeah.
It's as big as this is going to get.
Well, technically, there actually is a full screen option you could go to, but
When we deal with that in a moment, that's the stretch one. Is that the stretch? So here are the view modes. There's a full screen mode I see.
Mhm.
There's an auto adapt resolution that I have never used. And there's original and shrink. Original shrink is what I use all the time. So right now, suppose I want to read something.
Tiny print.
Okay, Times New Roman. This little bit there.
Well, Adam, you're kind of cheating there. A regular document would be like 12 or 14 point.
Now I'm really confused about which machine I'm on. I meant to put this on the other computer.
Sorry.
Yeah, now I'm a little confused.
Well, we'll maximize it and see where it goes. Yeah, you're on the remote machine.
Yeah, okay. So I'm on the remote machine, but I want to show about shrinking. So
Well, we'll
right
type
now
we'll type something.
I'm gonna write something.
But I have to point out you are kind of cheating by choosing 48 point type.
Okay. Okay. So now we've got this open. Now I'm going to go here and I can go to original. Make no difference at all.
Yeah.
I'm going to make this a little smaller. All right. So right now I'm in original mode. Let me go to shrink mode.
Oh,
Having no effect.
why don't you hit stretch just for comparison there?
Sure.
Yeah, so stretch made so this is about like putting a 5x7 photo in an 8x10 frame. The core thing that the software is doing is preserving the aspect ratio. But the shape of one of the monitors is not exactly the same as the shape of the other monitor.
Yes, I think that maybe I don't know if you're running into that, Tom, but it's really fun using the full screen, which I haven't done with any desk. It's a blast. Let me go back to the control. So I'm now in full screen mode. How do I get out? So I'll go here. I'm now genuinely confused.
Um,
Here it is. Look, there's like this cool control panel at the top.
yeah, you have to bang. I call that banging my head against the ceiling, or the mouse against the ceiling. Yeah, but you have a
Okay, that got me out of the full screen mode. Okay, but it was beautiful. Let's go back. I just want to show this off. I think it's really something special. So I'm going to go into full screen mode. Watch what happens. Now, of course, it's a little stretched. That iris looks a little like it's been on a diet, but it's pretty darn good. Like this is a pretty good. So I wonder, Tom, if you can play with some of these settings, if that might get you where you want to go.
Yeah, that is my hope, and I will report
Yeah.
this to class tomorrow night.
Yeah, my most objective way to say whether it's stretched or preserved aspect ratio is to look at anything that's supposed to be a circle. I couldn't tell from the plant, but I can tell from like the Google Chrome icon.
Yeah.
I know that's supposed to be a circle.
So I just chose auto adapt resolution. Do we have any idea what that means? What that does? There's full screen. And yeah, it's a little squeezed.
Yeah.
I'm going to bang my head against the ceiling here. This is some kind of weird menu, but here I am. I'm here. So I would love to know what auto adapt resolution does.
Well,
And
hang on while I ask the AI, and I'll tell you what it says.
okay. I'm going to ask it on Tom's desktop, Tom's imaginary desktop. So I'm going to say, oops.
Oh, it changes the remote computer's screen resolution so it fits nicely in your local window or monitor. Yikes.
Okay.
The original resolution is restored either when you put it back, when you turn that off, or when you close your session. but that could really scare the person on the other end.
Yes, indeed. So these are all the display settings. Let me give some examples. So you can choose quality, which is usually, that's also really interesting. I've never used this feature. Let's look at
Yeah,
quality.
in general, I only lean towards a quality choice if, for example, I need to see the same shades of color as the other person. Well, I normally go for performance,
But now
or just let it default.
bit confused. Okay, so I'm going to settings, and then I have display settings. So I'm on the laptop looking at Tom's, and I get to decide how I want to connect. So it's defaulting to best quality. It's showing remote cursor on movement. The view mode is by default optimized display, which is shrinking. Optimized screen usage, which is stretching. And then you have some choices. You could start new sessions in full screen mode. Exclusive full screen mode, hardware acceleration. Who knows what that is?
Well, that's where it tries to use your GPU or whatever to uh, uh, try to operate more quickly. But I think that's on your end.
Okay, so those are some of our choices. They don't mention here the auto thingy.
Well, that's probably because it's on their end, not on your end. This all sounds like your end choices.
I'm puzzled by this though, because it's at my end, but so here I am back in the laptop. In the laptop. Now I'm going to the desktop. So here I am on the desktop.
Well, Adam,
Yeah.
if you look at the upper left, there are two tabs in this window: the 853 tab and the settings tab. There you go.
I see.
Now you're looking at the desktop.
Yeah. Okay. So what you're saying,
Where you would open the AnyDesk settings on the desktop side. So now you're working at a meta level.
so what you're saying though is this is the settings over there on the desktop. So these settings seem different.
Well, right now you're
I
in Chrome.
picked the
You're not
wrong
in
settings.
AnyDesk.
Yeah. So where are the settings?
Okay, well, you're in Chrome right now. Yeah, so you reach down to the AnyDesk. Yeah, click there, and then yep, and now click the four lines up there. Yeah, now you're looking at the other computer's AnyDesk settings.
Yes, what I'm not unclear about is what these settings are. So let's go to display. So very similar.
Well, the thing is though, this is tricky. AnyDesk is a switch hitter. Anybody can help anybody else. So I think what you're looking at here is if the desktop computer were helping somebody else, these settings might apply, but I'm not sure they apply when it's being helped.
So how do you make settings apply when you're being helped?
I don't think you do. I think I think my sense is that when they affect what you're seeing when you're seeing someone else's computer. And if you're the one being helped, you may never experience that. In other words, these are receiver settings, not transmitter settings.
So here we are looking now using AnyDesk from Tom's laptop to Tom's desktop. And we've observed that there's some display settings that you can play with. There's some quality things you can do. There's some beta stuff. There's a thing about video, but that didn't do anything. And there's some gaming stuff. So you can capture the mouse.
Oh, geez, I've never used that. Boy, gaming features in AnyDesk. Who knew?
Yeah, they're thinking of there. Okay. Any other thoughts about AnyDesk? So just a couple of comments, if I may. I'd like to share with you the licensing issues of these machines. So what I'm gonna do is I'm gonna exit AnyDesk. But before I do it, I want to do good computer practices and lock this machine up. Okay. lock that up. I'm out of any desk. I'm back at this laptop. Yeah, back at the laptop. And I'm gonna lock this guy up too. Lock him.
Well, Adam,
Uh-huh.
did your laptop looks like it's still distorted by those circles aren't circles, so I'm not sure if the laptop might need its
This, okay, let's go back in. Let's see it. I mean, it was never very good. Remember, it's going through our admin.
Okay, sorry. I didn't notice when you started whether they were
Yeah,
just
yeah, it's not a real
stretched.
computer. It's,
Okay.
so I think what we're gonna do for our last discussion is talk about money. So let me talk about this a little bit because I think you will find it
Oh,
interesting.
Adam, your voice is kind of fading a little.
I'm just mumbling.
Oh, okay, but it seems like the volume might be down. I'm not sure if that's me or.
Can people hear me?
Sort of. You kind of dim. Listen.
That's interesting. I don't know why. I haven't changed anything.
Yeah, right. Just
well,
happening.
Testing 1, 2, 3. Testing. Testing 1, 2, 3.
Maybe check your Zoom microphone settings.
There is something funny going on because I'm not seeing the green. The green is very low.
Yeah, right.
It's using the right microphone.
Fading.
It's, I don't know. I'm going to test the speaker. Speaker's fine. Testing 1, 2, 3. Testing.
Very faint.
Adam, do you know how to check your microphone output?
I just did the test.
Well, if you click the little triangle to the right of your microphone icon in the bottom row of the Zoom window, and then choose the bottom guy, audio settings, one of the things you'll see is output volume. A slider.
Testing 1, 2, 3. Testing.
Same.
You see, that's output volume. That I mean,
Right.
my thing got louder. Hold on. I have to go to input volume. The input volume is being very weird. It's blanked out. It doesn't give me any choice. Oh, it's set to automatically adjust. Okay, let me turn that up. Testing 1, 2, 3. Testing. Testing 1, 2, 3. Testing. Still lousy?
Yeah. Yeah.
Don't hear much difference.
Interesting. Okay, so here's what I'm going to do. I'm going to stop the share. Martin is the co-host. I'm going to leave and come back in.
Okay.